The Family of High Military Low Class Bridging Program is a program that we have here at ERDC that leverages SMEs across the ERDC to evaluate the structural response of the improved ribbon bridge when subjected to extreme loading conditions. So we have SMEs across the ERDC. We have people from the Geotechnical and Structures Lab, from Coastal Hydraulics Lab, from Information Technology Lab. We also have the National Guard, the Mississippi Army National Guard involved in it, as well as people from Anniston Army Depot. We're able to look at the improved ribbon bridge. We're able to test it against different loading and hydrodynamic conditions and be able to determine operational conditions in which we can deploy the improved ribbon bridge and subject it to higher weighted vehicles.
The improved ribbon bridge is a float bridge that gives the Army the capability to cross their military assets across wet gaps that wouldn't be possible otherwise. The type of loadings that we were looking at, the improved ribbon bridge has never been verified to actually be capable of withstanding those types of loads. And we basically incrementally started to increase our load cases, not jumping into the heaviest, most potentially damaging load at first, but basically ramping up and taking a lot of measurements and inspections in between so that we could safely, approach our target goal of the heavier vehicles. In our modeling and simulation efforts, one important load case is to understand when everything is in static equilibrium, the vehicle is basically stationary on the bridge. What are our loads and stresses and displacements in the bridge? When we're analyzing things, it's a lot simpler, and a lot of the calculations are better suited to just looking at a static equilibrium case. But when the vehicles are actually moving, there's what's called a dynamic amplification factor, and you actually get loads that are higher than what you see when the vehicle is stationary. This was done for product manager bridging, who is responsible for acquiring and maintaining the Army bridge systems. What we were looking at is basically over time, the Army tanks have developed more capability, and they've also gotten a lot heavier. We bought the majority of our IRB inventory in the 2000-ish time frame. Since then, the vehicles have become heavier than what they were back then. And the question that the Army has for us that we try to answer is, can these existing bridge systems, do they have the capability of handling these heavier loads? The IRB is a robust bridge, and it has some significant capability. It's impressive the amount of load that it's actually able to carry.
What we will be doing in the future is we are going to take our results from our full-scale static flow testing, and we are going to validate it with our small-scale model testing that we have. And then from our small-scale model testing, we're going to look at different hydrodynamic conditions that we can operate this bridge in and be able to determine the operational conditions that we can deploy this bridge. And that will be the answer that we give the warfighter. We are also looking at doing a rafting configuration for the bridge.